This is the SIA 821 June 2014 question on specific heat capacity. So this here is talking about heating up amount of water, or we're cooling it down because we're using a fridge. And it's talking about a mass of 500 grams and that the temperature changes by 6.9 degrees when placed in a fridge for 20 minutes. Then it talks about another amount of water, 350 grams, at a temperature of 22 degrees. It is placed in the same fridge for 30 minutes. And they want you to find the temperature of the water after 30 minutes. Okay, and they give you the specific heat capacity value of water. Now, usually because it says the same fridge, we would assume it's the same temperature. However, if you remember, the energy depends on the power, which is IV, the current and the voltage, and the time. So for the 500 grams of water, the time that water was cooled down was for 20 minutes. But for the 350 grams of water, the time is 30 minutes. So therefore, because our time is different, our energy is going to be different. So first of all, I want to do is I want to try and work out, because I don't have current or voltage, I just sort of have a time. So I want to try and see if I could use this heat capacity equation to work out the energy for the 500 joules of water. So at this I have 500 grams. Okay, now to see if I have to change that into kilograms, I'm going to look at the specific heat capacity value. It is measured in joules per Kelvin per kilogram. So because that's in kilograms, I'm going to change the 500 grams to kilograms by dividing by 1,000. So that's going to be 0.5 kg. My change in temperature for the 500 grams is going to be this, 6.9. And we have our time. And then we finally need this specific heat capacity value of water, or C. So I'm going to use this equation here, and I'm just going to make a note, the energy for 20 minutes, because that is how long this 500 grams of water was cooled down for. So I'm going to do the 0.5 multiplied by my specific heat capacity value multiplied by my change in temperature. Okay, and that is going to give me the energy for 20 minutes, and that equals to 1455.5 joules. Okay, so that is 20 minutes. For the next amount of water, we need to find out the energy for 30 minutes. So what I'm going to do first is I'm going to find the amount of energy for 1 minute by taking this value and dividing it by 20. So for 1 minute, I'm going to take the energy for 20 minutes and divide it by 20, just to give me the energy for 1 minute. So by 20, and I get 722.78 joules. Okay, so that is the energy for 1 minute. Now to find the energy for 30 minutes, the amount of time that 350 grams is put into the fridge for, I'm going to take my energy for 1 minute and multiply it by 30. So the energy for 1 minute is 722.78 joules. And I'm going to multiply it by 30 to give me my energy for 30 minutes. And when I do that, 722. I'm going to get 21,683.4 joules. Okay, so now when I look at my specific heat capacity equation, I now have the energy for 30 minutes. I have my mass, remember this grams is going to have to be turned into kilograms, so I have my mass of 0.35, and I have my specific heat capacity value. So I'm going to rearrange this equation to give me my change in temperature. So if Q is equal to my mass times my specific heat capacity value times my change in temperature. At the minute, the change in temperature should be multiplied by C and M. To get rid of those, I'm going to divide both sides by the mass times the heat capacity value. So my change in temperature is equal to Q divided by my mass times C. So now all I have to do is just put in my numbers. So I have my energy 3.4 divided by my mass, the 0.35 kilograms, multiplied by my 4190. And that's going to give me my change in temperature. So when I type that in, I get a value of about 14.7 degrees. So that means the difference between my initial temperature and my final temperature is 14.7 degrees. And what they want us to find is the final temperature. Now, because we're putting it into a fridge, it's not heating up, it is cooling down. So if the starting temperature is 22 degrees, then the final temperature is going to be 22 degrees, take away this change in temperature. So my final temperature is going to equal the starting or the initial temperature, take away this change in temperature, take away the 14.7. So my starting temperature is 22, take away 14.7, and when we do that, we get 7.3 degrees, and that is your answer. So it is difficult, but the only reason it's 5 marks is because you have to realise that although it's the same appliance, they're heating for different amounts of time, so therefore the energy is different.